What's up, Simpsonites? Back at it again, Sim Science Sunday, just like the old days. I know it's been a while. I know you guys missed this like crazy and have been freaking out, but we're back at it. We're going to do some sweet science, Sim Scientists. Okay, so we got the study guide here. As you can see, I put answers to these questions. I kind of like. Did I miss one? Oh, I'm going to touch on that. I kind of like this approach. It makes you actually do the question, then you can see if you're doing the math correctly to get the answer. Obviously, I need to see the work for you to get your credit. So let's approach some of these questions. I'll walk you through some of them. I don't think I'm going to work any of them out completely. I don't think I will. But what I'm going to do is if you have a specific problem you want to see worked out, if you have something that you're caught up on, comment the question down below, the number, and I will either make another video answering it, or if you have a problem that you haven't been able to work out yet, then come to me tomorrow. You have time before the test. If you have time fourth period and free fourth period or lunch, then we can do that. So let's talk about these. So first of all, what is plasma? Now I put this question in here, it doesn't really fit in, but because I just wanted to touch on what plasma actually is. So we obviously have solid, liquid, gas, increasing energy as you go through those from solid to gas. It's endothermic as you go from solid to gas, absorbing energy. Now, but what is plasma? So plasma at a gas state, so in a solid state, you have everything really rigidly combined together, in a structure like that. And then liquid, some of these bonds start breaking. And then gas, like let's say you have O2 gas, it's just oxygen, they're all flying around loose. Now when you get to plasma, you start actually breaking these bonds. Okay, but you go beyond that. So you not only do you have loose oxygens, okay, but they're breaking apart. So you have protons flying around, you have electrons flying around. So these are breaking up into their separate subatomic particles. That's what plasma is. When it's so much energy that it breaks the atoms into the parts that make up the atom. Okay? Now Boyle's law. P1 V1 equals P2 V2. All right. So this is Boyle's law. As far as these questions go, you just have to apply. You have to identify your variables, plug them in, do the math, sig figs, keep sig figs in mind, and keep your units in order. So for this one, you should have been getting 7.54 ATM. This is also Boyle's law 1 down here. I think some people were confused when you were doing this about what was P1 and P2 and V1 and V2. So it's saying that you're starting with this volume of a tank with this pressure, and then what would the volume of ammonia be if its pressure's changed to this? So this being P2, what pressure would you have to change it to? And obviously temperature remains constant. Okay, here are the answers to the Charles law questions. I don't think there's anything too complex here. Let me do Charles law. My bad. Okay, so we have V1 over T1 equals V2 over T2. Okay, so you got to plug those in. Now cross multiplying helps here if you're trying to isolate a numerator. So it's V1 T2 equals T1 V2. All right, so this is the same thing as the fraction, but it's a lot of times easier to isolate using that equation. Okay, inversely proportional relationship. I'm sorry, directly proportional. So you increase volume, increase temperature. The two happen together. Whereas with Boyle's law, if you decrease pressure, you increase volume. All right, so there are those ones. Gay-Lussac's law. We have P1 over T1 equals P2 over T2. Same thing as saying P1 T2 equals P2 T1. Same thing. So when pressure goes up, temperature goes up. Okay, so these are the answers to these ones. This one, number 7 here, is a little bit tough. So this is a 30.0 liter sample. So you think, wait, volume? There's no volume in this. This is just pressure and temperature with volume held constant. But that's what it's saying. It's saying it's a 30.0 liter sample, and it stays a 30.0 liter sample. That volume does not change. Okay. So yeah, I think that's pretty much it for those ones. If you have questions, let me know. Combined gas loss. This is where you put them all together. So this is where we had P1 V1 over T1 equals P2 V2 over T2. So this is where you really got to list out your variables and get everything organized to answer these. Make sure we're converting to Kelvin if it's not in Kelvin already. Significant figures. Okay, so this number 9, a lot of people are confused that. So you're at standard temperature and pressure. Standard temperature and pressure, you can look up, it'll be on your reference sheet, is 0 degrees Celsius and 1 ATM. But you're not working with ATM here, you're working with this. So you have to figure out, just Google, find your answer, or convert 1 ATM to these units and figure out what your pressure is going to be at STP. Okay, I think that's the only thing that was a little bit tricky there. Okay, Avogadro's law. So this is where we talked about how Avogadro talked about how volume of gas is directly proportional to the number of moles of a gas. Specifically, no matter what the gas is, if it's at STP, it'll take up, 1 mole will take up 22.4 liters. So we represent this with V1 N1 equals V2 N2. So when the number of moles goes up, the volume goes up, and that makes sense, right? We put more stuff in, it's going to get bigger. Ideal gas loss. So this is where you put everything together, including Avogadro's principle. PV equals nRT. Pressure, volume, number of moles, gas constant, which is given to you here, and temperature. So for this one, the only thing I remember people being confused about was this is N. That's your number of moles. Okay? Now these ones, like I said, these are the best ones to test your knowledge with. If you work through everything else, it's kind of laid out a little more organized as to which problems they are. These ones, oh, where'd they go? These ones, I'm not telling you which one, what law to use. Some of them you'll have to use, one of them you have to use Boyle's, one you'll have to use Charles, Gay-Lussac, combined. So that's up to you to identify what variables you have, what you're trying to find. Okay? When I work through these, I don't think there's anything that really caught me up too much. I let you guys know what sometimes I feel like the answer with the correct significant figures might confuse people, so I put the actual answer, or not the actual answer, but the full digit answer. But yeah, just work through these, identify variables. When you get a value of pressure that's different, that's okay, as long as you keep it in these units. You can just keep the same values, convert to Kelvin, etc., etc. So yeah, work through all of these. If you get really stuck on one, comment it down below, or maybe you guys can help each other out and comment a question you're confused on, see what other people did. That's always a great way to learn for both the person helping and the person receiving help. So comment questions. If you're really confused on one or two, I can probably work through them today, or come in tomorrow with that at some point, with those questions at some point, and we can look at them together. All right, thanks guys.